are made. They are one of the most complex machines ever created, and the process of manufacturing them is a fascinating feat of engineering. Airplanes have revolutionized transportation, commerce, and even warfare, allowing people and goods to be transported across the world in a matter of hours. In this video, we will take a deep dive into the manufacturing process of airplanes and explore how they are designed, constructed, and tested. Did you know that the first airplane was invented over a century ago by the Wright brothers? Since then, airplanes have come a long way, and the technology and materials used in their manufacturing have evolved significantly. In this video, we will take a closer look at the design and concept phase, the materials and manufacturing process, and the assembly and testing phase of airplane manufacturing. Whether you're a frequent flyer or simply fascinated by engineering, this video will provide a detailed insight into how airplanes are made. So fasten your seatbelt and get ready to take off with us on a journey into the world of airplane manufacturing. The design and concept phase of airplane manufacturing is where the process begins. Engineers and designers work together to create a blueprint for the airplane, taking into consideration factors such as aerodynamics, weight distribution, and safety. This phase is crucial, as any mistakes or oversights at this stage could have serious consequences later on in the manufacturing process. One of the most important aspects of airplane design is aerodynamics. Engineers use computer simulations and wind tunnels to test and refine the design, ensuring that the airplane will be able to fly efficiently and safely. They must also take into account other factors, such as the weight and balance of the airplane, the placement of the engines, and the materials that will be used in construction. Some of the most famous airplane models, such as the Boeing 747 and the Airbus A380, are known for their unique design features. The Boeing 747, for example, has a distinctive hump on the upper deck, which houses the cockpit and provides extra space for passengers. The Airbus A380 has a double-deck layout, allowing for more seating and reducing the noise level for passengers. Advancements in computer technology have revolutionized the design process, allowing for more precise and efficient modeling. Engineers can use computer-aided design (CAD) software to create detailed 3D models of the airplane, which can be tested in virtual simulations before any physical prototypes are built. In conclusion, the design and concept phase of airplane manufacturing is a crucial step in creating a safe and efficient aircraft. Engineers and designers use advanced technology and simulations to refine the design, taking into account factors such as aerodynamics, weight distribution, and safety. The end result is a blueprint that serves as the foundation for the rest of the manufacturing process. Once the design and concept phase is complete, the materials and manufacturing process can begin. The materials used in airplane manufacturing must be strong, lightweight, and able to withstand extreme conditions such as high altitudes and rapid changes in temperature. Some of the materials commonly used in airplane construction include aluminum, titanium, carbon fiber composites, and high-strength alloys. The manufacturing process involves the creation of various components such as the fuselage, wings, engines, and landing gear. The manufacturing process for each component differs depending on the material used and the component's design. For example, the wings may be created using a process called extrusion, where long pieces of aluminum are formed into the desired shape, or they may be constructed using carbon fiber composites, which are layered and cured in a mold. One of the most significant advancements in airplane manufacturing has been the introduction of robotics and automation. Robots can perform repetitive tasks with precision and speed, increasing efficiency and reducing the likelihood of human error. For example, robots can drill and install thousands of rivets in the fuselage, ensuring a secure and consistent bond. In addition to robotics, airplane manufacturing also relies heavily on computerized systems and digital control centers. These systems help monitor and manage the manufacturing process, ensuring that the aircraft components are constructed to precise specifications and safety standards. Once the individual components are complete, they are assembled together to create a complete airplane. This process involves attaching the wings, engines, landing gear, and other components to the fuselage. The components are carefully fitted and secured, ensuring that the airplane is safe and efficient. Throughout the manufacturing process, rigorous quality control checks are performed to ensure that each component meets the required safety standards. Components undergo stress tests and other safety checks to ensure that they are capable of withstanding the stresses of flight. Once the airplane is complete, it undergoes a series of flight simulations and safety checks before being cleared for use. In conclusion, the materials and manufacturing process of airplanes is a complex and precise undertaking. Strong and lightweight materials such as aluminum, titanium, and carbon fiber composites are used, and the manufacturing process involves a combination of manual labor, robotics, and digital control systems. Quality control checks are performed at each stage of the manufacturing process to ensure that the airplane meets the required safety standards. The end result is a machine that is capable of flying safely and efficiently through the skies. Once the airplane's individual components are manufactured, they are assembled into a complete aircraft. The assembly process is a complex undertaking that involves fitting the various components together and integrating them into a functional machine. The assembly process begins with the fuselage, which serves as the core of the airplane. The wings, engines, and landing gear are attached to the fuselage, and electrical and hydraulic systems are installed to ensure that the airplane's various systems can communicate and operate smoothly. As the airplane is assembled, it undergoes a series of safety checks and tests to ensure that it is constructed to the required specifications and safety standards. For example, the wings are tested to ensure that they are level and that the control surfaces are functioning correctly. The landing gear is tested to ensure that it can handle the stresses of takeoff and landing, and the engines are tested to ensure that they can generate the necessary power to lift the airplane off the ground. Once the airplane is fully assembled, it undergoes a series of flight tests to ensure that it can operate safely and efficiently. The flight tests involve simulating a range of flying conditions, such as takeoff, cruising, and landing, to ensure that the airplane can handle these conditions with ease. During the flight tests, data is collected and analyzed to identify any issues or areas for improvement. This information is then used to make adjustments and improvements to the airplane's design or manufacturing process, ensuring that future airplanes can be even safer and more efficient. The testing phase of airplane manufacturing is a critical step in ensuring that the airplane can operate safely and efficiently. It involves a combination of simulation and real-world testing to identify any potential issues and ensure that the airplane can perform at its best. In conclusion, the assembly and testing phase of airplane manufacturing is a complex and rigorous process that involves integrating the various components into a functional aircraft. The airplane undergoes a series of safety checks and tests to ensure that it is constructed to the required specifications and safety standards. Once the airplane is fully assembled, it undergoes a range of flight tests to ensure that it can operate safely and efficiently. The data collected during the testing phase is used to make improvements and adjustments to the airplane's design and manufacturing process, ensuring that future airplanes can be even safer and more efficient. Airplane manufacturing has come a long way in recent years, with advancements in materials, robotics, and digital control systems allowing for safer, more efficient, and more sustainable airplanes. The manufacturing process continues to evolve, with manufacturers striving to create airplanes that are even safer, more efficient, and more environmentally friendly.